if you were asking questions about how I made my own car, what materials I used, how I designed it, and how I made some of the different systems on it work. So I decided to make this brief tutorial on how I made my car, and hopefully I'll explain some of the things and answer some of your questions. So in starting such a project, the first step is obviously to design the car. I started off with measuring the components that I was going to be using. I was using an engine from a 2000 Honda Civic. So first I measured out the engine, transmission, and some of the other components that I was using from this car, like the battery, the radiators, some of the suspension components. Then I went ahead in 3ds Max and made those components first. So I knew what the sizes were. I didn't go too much into the detail of making every single bolt, every hose, wires, all that, but just made them good enough so I had an understanding of how much space each component would take and where it had to be fitted, so I could design the frame accordingly. So yeah, I chose to place the engine at the back, and the axles coming out as a transmission, they had to line up with the rear wheels so uh, the axles could be fitted properly. Then I went on to the driving position where the pedals needed to be placed, where the steering needed to be, and also other components like where I needed to place the radiators, where I needed to place the suspension, brake booster, some other main components. And then I basically designed the frame around that, so the frame would be big enough to fit the engine, and but not too big to add any excess weight to the car. I didn't really go into doing structural analysis of the frame or anything. I just did some rough calculations to figure out that my frame would be strong enough to um, for the purpose I was using it for. But it's better if you do a proper structural analysis. It can help you save more weight, so you're not adding any excess weight to your frame, and you're just making it strong enough to for the purpose you're making it for, but not carrying any excess weight on it. So after I had designed all the frame, I took the measurements from the software. Like if I click this tube over here, it will tell you what the length is, 6.3, which meant 63 centimeters. From here I went ahead and I made these rough blueprints uh, from which I knew how long to cut each tube and where to place it and what angle to place it at. So yeah, these were my two blueprints. This is a 63 centimeter tube that went on the front hoop. I used hot wound steel, 1/8 of an inch thick, 2.5 inches in diameter. But it's much better if you go with cold wound steel, or chromoly would actually be the best option for this type of project because it's a really strong grade of steel and it will help you save weight because you won't need to use such a thick wall thickness if you're using chromoly, because even a thinner wall thickness would have the same strength of let's say a 1/8 inch equivalent hot wound steel. Yeah, here I cut the steel tubes to size. I shaped the ends using an acetylene torch and then angle grinding them so they fit into the other tubes better, to reduce the gap between the tubes and to make sure it was easier to weld, and also the welds were strong. These are the two side tubes for the frame. I actually drew a small diagram on the floor and taking measurements from the software, so I knew how to shape them. I just gave them a cut and then welded them. So yeah, this is the lower part of the frame. These are the tubes you saw on the floor. Um, yeah, right now I was welding with an acetylene torch, but later on I used a MIG welder, which is a much better option to use for this type of a project. TIG welder would actually be the best option, but I didn't have a TIG welder available, but and it also takes a long time if you're doing TIG welding for all your welds. This is the upper part of the frame, and then I welded the two parts together. And over here I welded the rollover hoop and the front hoop. So yeah, now I got onto the suspension. So up till here it took me about 2 weeks to get to this point. So it's really not that difficult making the chassis, but you just have to make sure that all your measurements are right, all the alignment is right, just to make sure that you don't have any issues later on in making the car. Because if the sizes aren't right, some of your components might not fit according to how they were supposed to fit, and things like that. Also, your wheel alignment or suspension alignment could go off if your frame is not that accurate. So it's best to take time and make it as accurately as possible. So this is where the suspension, the lower control arm was gonna mount for the suspension. This is the solid mounted bushings that I used. I just took a tube and welded this in it. So basically, this nut goes straight into the bushing. This is a Honda rubber mounted bushing. I didn't go with the rubber mounted bushing because it takes away from the feel of the car a little bit. It's more of a comfort feature. Here I welded the control arm in place. I had to make sure that this place where the ball joint mounts on the lower control arm was right at the place where it was meant to be, because if this is off, then it could your suspension angles could be off. Yeah, here I've placed the upper control arm in place. Originally, I wanted to make my own upper control arm too, but later on I decided just to go with a Honda upper control arm just to save time. But I wish later on that I had made the upper control arm adjustable, so the camber of the car and the caster angle were adjustable, which would have helped later on in fine-tuning those angles, making just changing the suspension setup around. But yeah, the hardest part of the suspension is making sure all your angles are right. The track of the car, because if you're using a steering rack from another car, you need to make sure that it will fit in this car. So you need to make sure all the angles are right. The caster angle for the front suspension, especially. You need to make sure what caster you need to keep for the front suspension, because depending on that, it's gonna affect how your steering feels in your car. Here I bolted on the wheel just to make sure all the angles were right. Yeah, I cambered the front wheel slightly to, I think they were cambered at 2.5 degrees or 3 degrees to basically help the traction better in the corners when the car was turning. Here I've welded the push rods in place and the coil spring. This part of the suspension was adjustable, so I could change the length of the push rod to change the height of the car, and also I could move the coil spring around to change the leverage, to basically change the stiffness of the suspension setup. So if I wanted to make it stiffer, I would move it up along this thing, and if I wanted to have a softer balance, I'd move it downward, so it changes the leverage. I placed the engine in the frame just to weld all the mounting places where the engine would mount to the chassis. Again, I was using solid mounts, just bolting the engine straight into the chassis, because this helps add rigidity to your chassis. It can help you save weight because you don't need to add excess steel supports to add that rigidity that you can just gain by bolting the engine directly to the chassis. So here I was making the rear suspension and making sure the axles were in the proper place. They fit right into the transmission, and all the suspension components could fit around the engine. Nothing touches with each other and things like that. So here I was making the steering system. It was a little tricky to make this because I was using the steering rack from a Honda Civic, and it usually sits in front of the driver's feet, and the steering usually fits on the right side of the car because this was from a right-hand drive car. But since on my car the steering wheel was placed in the center and the steering rack wasn't exactly where it sits in a Honda Civic, so I had to place these series of gears at the front. So when I move the steering wheel, this gear rotates, it rotates this gear, and then this transmits the rotational motion to the steering rack. I also used different sized gears. This gear was bigger than this one, so basically one rotation of the steering wheel could mean 1.5 rotations or something like that of the steering rack. So basically I didn't have to turn the steering wheel as much to move the car. So here I've gone on to painting the car. I've primered it to protect it against corrosion, rust. And after that I painted it. By this point you need to make sure that all your welding work is basically complete. All your places where things need to bolt on, all those things are complete, because if you do them later on, then you're gonna need to cut your paint off again and grind your paint off and then weld again, and then paint again, so it's gonna be a really difficult process. So yeah, after this I just bolted all the components back into their places. Here I've mounted the turbocharger where it needs to go. Originally I planned that the turbocharger would sit over the transmission, but because there were a lot of other things over the transmission, that's why I had to place the turbocharger outside the frame. Over here is these two motors were the motors that controlled the transmission and shifting gears, because this was a manual transmission originally from a Honda Civic, but I converted it to an automated manual. So basically I would just push a button and the computer would automatically operate these motors to engage the next gear. This over here was the system for the clutch. So a motor could operate the clutch, engage it or disengage it. And this over the engine was another injector rail, a second injector rail that I used to increase the fuel because it needed more fuel with the turbocharger. So there were in total 8 injectors with this car, and these injectors were being controlled by another ECU that I made. This was the ECU that I made for it. I'm not going to explain it too much. This ECU was controlling the engine and the transmission. I also left the Honda ECU in to manage basically the idle speed, the temperature, things like that. But all the performance things, the fuel level, the air fuel mixture, things like that, they were being controlled by this ECU. Also all the gears, the transmission things were being controlled by this ECU. It worked pretty well. So this is the complete car now with all the components fitted. So it took me about 2 months to basically get the car drivable, but I had 2 months, then I had to go back to university, then came back a year later and fitted the turbo and some of the other systems, also my own ECU. So yeah, in total it took me about 4 months to complete the car. At first there were some reliability issues, some of the electronics weren't working right, mostly programming issues that I had to fix later on, but yeah, once everything was fixed, it was pretty fun to drive. The performance was pretty good. So this is a short video of the car. That gauge beside the instrument cluster was the boost gauge for the turbocharger. That whining noise, by the way, is the fuel pump. I was using 2 fuel pumps in this. They were Honda fuel pumps. That black pipe on top is the pressure pipe for the turbo. That black cylinder sitting on top of the engine, that's the fuel filter, and all these yellow hoses are fuel hoses. This is the turbocharger. I limited the revs to 4,000 RPM when the car was not moving, so just to protect the engine. Yep, I hope this video was helpful, and thank you for watching.